Type 7, graphing and solving quadratic inequalities. It's calculator work. This should be part of your favorite subjects because we just graph using the calculator. I do want you to transcribe correctly on your paper, but that's about all there is to it. We're going to graph y is greater than x squared minus 2x minus 3. Let's remember how we do this. We go to y equals, and right now you have a line there. We said we're going to go over. Oh, I need to clear out first. That's why I didn't do it. Hold on. Let me do this. Let me clear it out. Okay, now I'm going to move over. You notice how my line is now blinking. I'm going to hit enter. I'm looking for a greater than. So I need the little thing that points up right there. I'm good. I'm pointing up. I can now come and put that in there. X squared minus 2x minus 3. You see this? Just put it in. But now I have a little arrow that points up. And now I'm going to go zoom 6 every single time because I don't want to mess with my zoom. This is going to graph it for me. All I have to do is transcribe it. Now, I need you to get that vertex out for me. And I need you to get the axis of symmetry. Let's remember, we do trace. There's my little dot. I go down on it until I get to where it's flat. And my vertex is really negative 4 and 1. I can tell that by looking at it. 1, 2, 3, 4, 1. That's my vertex. That's my axis of symmetry. From here on, I don't care that you graph it correctly, but I want my vertex of 1 and negative 4, okay? And now we're shading inside because that's where everything is greater than. How would you know that? If I would just pick the point right there, x, if I would make the point 0, 0, and I want to check, is this correct? Is 0, 0 checking this inequality? 0, 0, which means x is 0, y is 0. That means y has to be greater than 0 squared minus 2 times 0 minus 3. Well, that's 0, that's 0. Is 0 greater than negative 3? Yes, it is. So if you ever want to know how, you just pick a point in there and you check it and it works. Okay, you can pick any point. 0, 0 is the easiest one to plug in. This is 0 here, not y. Right? And it checks out. But you don't need to because the calculator does it for you. So every time you have to graph this, you plug it in your calculator. Please get the vertex out, get the axis of symmetry out, and then shade wherever the calculator tells you to shade. We have a word problem on the next page that we want to solve. And it talks about you're building a wooden bookcase. I need a bookcase. I really do. But you have an inequality. W equals 300d squared. Please never get confused by this. W in your calculator will always be y. Whatever is on this side is always going to be x. Okay, so we can rewrite this as y is less than or equal to 300x squared. Okay. If you look at D is inches. Okay. W is weight in pounds, which means D is a lot smaller than W, okay? So I'm going to go back and I'm going here. I'm going to clear it out. I'm going to go up. Sorry, I did not do it right. I'm going to clear it out. When I clear out, my little thing disappears, right? So I have to go right back in, right there. And now I'm looking for less than. So I'm going to hit enter until I get that little arrow pointing not up, but down. I got that pointing down. I go back out. And now I just put 300x squared. That's what we're doing. Now, we're not going to do zoom 6. You're not going to be able to see this on zoom. Actually, you might. I can't tell. Let's try it. Zoom 6. I got nothing to lose. Now, see, you're not going to be able to really see it at all. Look what I got here. This is not good, right? And here's why you're not good with this. Because this is a real life situation. This is the place where we play with our window, right? Real life situation, my x minimum is 0. My x maximum, this is the dimension. I don't need it more than 5. We're talking about inches, so it's going to be small. My y scale stays 1. My y minimum is 0. Look at this. You're starting with your weight at least 300. So I would make my weight at least 300, okay? So my y max is 300. And I can make my scale by 50. It doesn't really matter. The scale doesn't matter that much. But here's my table now, okay? Real life situation. X minimum and Y minimum will be 0. We don't have negative solution. And now I hit graph. Here's my graph. And I can graph it, right? I just transpose it and I go real life situation. It kind of looks like this. All of these are my solutions. And that was your number 1. It says graph the given inequality with this. It says, if you make each shelf 75-inch thick, can it support a weight of 60 pounds? That tells you, if weight is 60, and your D, let me write this again, 0.75, you want to know if this checks it or doesn't check it. So you put 60, has to be less than or 300 times 0.75 squared. You're going to put this in the calculator. 300 times parenthesis 0.75 squared. I get, if I do that math, 168.75. 60, it is less than 168.75. So yes, it checks, right? It absolutely checks the inequality. We're good. Now, what if we have to graph a system of inequalities? If we do have to do that, we're not going to panic at all because we know how to do this using a calculator. We're going to graph y greater than or equal to x squared minus 4, and y is less than negative x squared minus x plus 2. Please remember, this is going to be a continuous parabola. This is going to be a dotted parabola. Why? This is a less than, that's a greater than or equal to. Let's go ahead and go back to y equals, clear it out. First one is greater than, we're going to do 2 sets over, enter, enter. I am getting the one that blips up, go back out, x squared minus 4. I'm not done. I'm going to move down to y2. I'm doing 2 inequalities, right? Going to y2 again, I'm going to move over. I need a less than, so I'm going to go not up, but down this time, right? The second one points down, and this is negative x squared minus x plus 2. Now I have 2 inequalities, and now we're going to do zoom 6 every single time. Unless we have a word problem, we're always going to do zoom and 6. And we're not going to panic about it because look, it's going to graph it for us. You see it? So we're going to literally look at this and go, well, I have one that comes like this, and I have one that kind of comes like this. All I need you to do is please shade the solution. That means wherever it overlaps, okay? That's all you need to do, is do it wherever it overlaps. So make it and then shade whatever overlaps, and then you're done. That's how we do this stuff. Now, the last part of this lesson is not necessarily a calculator work, but we can use a calculator for it. If we have to solve x squared minus 6x plus 5 is less than 0. We're now solving an equality, right? It's not y equals something, it's something equals 0. So this is pretty much not good, right? So we want to know first, what are the solutions of just the equation? I can factor this out. This can be written as x minus 5, x minus 1 has to be less than 0. How did I do this? This is 5.3 factoring. 2 numbers that times to positive 5 add to negative 6. Negative 5 times negative 1, positive 5. Negative 5 plus negative 1, negative 6. So my solutions are x equals 5 and x equals 1. If I go to my graph and I just clear everything out and I just graph it, we're not going to have an equality sign there. I'm just going to go x squared minus 6x plus 5, and then I go zoom 6 just to make sure that I graph it correctly. Here's my equation right there, and you see my solutions. It's 1 and 5, right? I'm looking for where is this less than 0. So if this is my x is 0, I'm looking for all the solutions underneath. So in between 1 and 5, all of my solutions are negative. So I'm going to write the solution as x has to be greater than 1 but less than 5. We did this in class and I explained this to you in class also. Here's why. All of this is negative. Everything on top of here is positive, right? X and y are positive. This is where the negative values are. So it's in between 1 and 5. right? It can be greater than 1, less than 5. Why did we not put equal? Because this has to be less than 0. At 1 and 5, they equal 0. Okay? That's how you find your solutions. Let's find another one. And see how we solve it that way. And this is actually going to be a little bit easier with a calculator. 2x squared plus 3x minus 3 equals 0. 2x squared plus 3x minus 3 equals 0. Well, it's not equal 0. It has to be greater than or equal to 0. Sorry. Okay, we're looking for this. We're looking at this, and this does not factor. It's very easy to see. If you move the 2 in the back, you get a negative 6. There are not two numbers times negative 6 and add to a positive 3. This is where the a equals 2, b equals 3, c equals negative 3. Quadratic formula comes in. X equals negative 3, negative b, plus or minus square root of b squared or 3 squared minus 4 times 2 times negative 3, 4ac, all over 2 times 2, 2 times a. This is a calculator work, you can do it. I'm going to move this fast. 3 plus or minus, this becomes a positive 12, 24, plus 9, 33, all over 4. I have two different solutions, right? I don't know what they are exactly, but I can put this in the calculator and go, what is negative 3 plus square root of 33? And it's done in my book. I get one of them is 0.69. The other solution is about negative 2.19. Now, I need to know where is this greater than 0. So I'm going to have to come right back and graph it. Y equals, clear it out, 2x squared plus 3x minus 3. Right? Zoom 6. I get this. There's my graph, and I'm looking for all the numbers that are greater than or equal to 0. We said all of them are on top of that line, right? So this time, my solution is either x is less than or equal to negative 0.19, or x is greater or equal to 0.69. Why am I using the equal? Because they're using the equal in my problem, and I'm looking at this. All the numbers that pass negative 2.19 are positive. All the numbers that pass 0.69 are positive. So these are the outside solutions, right? That's where we're looking at. And so you look at them and you always go, am I looking for the positives? If you have this graph, like the way it was here, if I'm looking for the positives, it's either all the numbers here give me a positive outcome. If I'm looking for the negatives, all the numbers in here give me a negative answer, right? Depending on what those are. Now, they want you to solve something algebraically, and I don't know that we need to or don't need to, but we're going to do it just for the sake of it. X squared plus 2x less than or equal to 8. Again, you can the exact same way solve it like before, but we're going to look at this. We're going to solve this like an equation initially. Remember, this is what we erased. I'm going to write it there so we know what we erased, right? So let's go ahead and move the 8 on the other side. X squared plus 2x minus 8 equals 0. This can be easily factored. How do I know this? Negative 8. I get a negative 4 and 2, or a positive 4 and 2. This is a x plus 4 and x minus 2. When I add them, I get a positive 2. When I times them, I get a negative 8. So I get x equals negative 4, or x equals 2. I put this in the number line. Here's my 0 just as a thought process. I get a 1, 2, 3, 4, negative 4. 1, 2. This is my turn. I put my solutions. And now I want to know where in between this, keep in mind we started with this. It has to be less than 0. Where in these three intervals, which I have either from here to here, which is negative infinity to negative 4, or negative 4 to 2, or 2 to positive infinity. Which one of these work for my equation? And all I have to do is test. I test 1 point. I can test 0. If I put 0 here, will this work? 0 squared 0 plus 0 minus 8. Is negative 8 less or equal to 0? Yes. So this 0 checks. I checked one solution. I know it works. I can pick negative 5. Negative 5 squared gives me 25 minus 10, 2 times negative 5 being 9 minus 10, minus 8. It has to be less than or equal to 0. By now, you should know this not work. This is 7. It is not less than or equal to 0. So this is not a solution. This is a solution. This is not a solution. And I can also pick 3 and see if it works. 9 plus 6 minus 8 should be less than or equal to 0. 15 minus 8, 7, less than or equal to 0. 3 did not work. So the only interval that works is in here. You want to check and see where your solution works. You pick a number from each of them. This was your 5. So you go from here to here, pick one. From here to here, pick one. From here to positive infinity, pick one. Really pick the next one over and see if it works or doesn't work. Okay, we're going to do the word problem now on example 7. It talks about a driver and the reaction time. I wrote the equation on the board already for you. This was plus 22, and the reaction had to be, let me do it that way, plus 22, this equation. And this was going to be greater than 25. The question, it says, if that's the equation for ages in between 16 and 70, they say, when is the reaction time greater than 25 milliseconds? To move this over, I would have to minus the 25, which gives me this a negative 3. 22 minus 25, negative 3. 25 minus 25, 0. We're going to graph this, right? We're going to go to y equal. We're going to put it all in the way we have it in here. We're going to play with our window. We already know the age gap. We need 16 to 70, so x minimum 16, x maximum. I went a little bit lower and a little bit higher to give me a little bit of leeway. And then I made my y minimum 10, my y maximum 30, just to see the parabola forming. And then I'm going to hit graph. And here's my parabola. Again, we're looking for numbers greater than 0. Here's what we do know. We know that my upper limit is 70, so it's not going to be anything over the 70. That's where they did this subject. My lower limit, I don't know. Where are these numbers greater than 0? So all I need to do is find that y-intercept right there, right? So if I hit trace, and I go all the way with my little dot, if you notice, I'm moving my little dot until I get there. Let me see, because I can't look at that and look at this. Hold on, I passed it. If I get there, this is the closest I can get to 0 for y, and it's 56.9, or it's 57. So in between 57 years old and 70 years old, your reaction time is more delayed. It's over 25 seconds. So all we did is we graphed the actual equation. We know the upper limit, it's 70. I don't need to worry about it. I just need to know where it starts. And it starts at that y-intercept that we hit trace to find it. Okay, happy homework.